My apologies for the delay in getting this video up. The other one that I had saved is no longer saved. I deleted it. So we have to move on now to what's called enthalpy of formation. I know there's a lot of enthalpies coming out there, but remember, enthalpy is nothing more than energy or heat. So we have something now we have to talk about that's called standard enthalpy of formation. You can read the definition, but very simply put, basically it is the amount of heat involved when 1 mole of a substance is formed from its elements. And they talk about standard states here. So standard state means nothing more than it's occurring at 1 atmosphere pressure and 25 degrees Celsius, very similar to STP in the gas laws. So the enthalpy formation of free elements in their pure form is equal to 0. That means, for example, in its pure form at 25 degrees Celsius in 1 atmosphere, oxygen is O2, not O3, which is ozone. So basically they're saying when something exists in its normal state at 1 atmosphere and 25 degrees Celsius, its enthalpy of formation is considered 0. So I pulled up Appendix C from our Pearson textbook, and I'd like to take a look at that. So if you look here, it shows you that formation for aluminum, the enthalpy of formation is given a value of 0. The same goes for barium in its solid state. And if we go down here and look, you can see that calcium in its solid state is given an enthalpy of formation of 0, but in its gaseous state, which is not its pure form at STP conditions, it has a value of 179.3. So here's an example of how we can use this information. Refer to the above table, how much energy is involved in the formation of 1 mole of CaCl2. So by definition, enthalpy of formation is the amount of energy involved with the formation of 1 mole of a substance. So right here we can see for calcium chloride, we're going to have to go back to the table here, and there in red, there is a enthalpy of formation for calcium chloride, negative 795.8. What does that mean? That means for every 1 mole of calcium chloride that is formed, 795.8 kilojoules of energy will be given off. So to answer the question, refer to the above table, how much energy is involved in the formation of 1 mole of CaCl2? It's right here, negative 795.8. Based on the answer, is a process endo or exothermic? Well, since delta H of F is negative, it's going to be an exothermic process. We can write that in what's called a thermochemical equation. Exothermic means we're producing energy. So calcium, it's a free element, plus chlorine, a free element, will form calcium chloride, and it gives off 795.8 kilojoules of energy. Shown it as plus energy indicates that it is an exothermic reaction. Let's apply this now to a problem. How much energy will be given off from the formation of 56.36 grams of calcium chloride? Well, we know that based on the enthalpy formation, 795.8 kilojoules of energy will be given off or produced for every mole of calcium chloride that is formed. The 56.36 grams of calcium chloride must be converted to moles in order to make use of this information. So basically, I took 56.36 grams of calcium chloride, converted to moles, multiplied it by its enthalpy of formation, and we are going to produce 404.2 kilojoules of energy. Now, I didn't put the negative sign down because it's just asked me to calculate how much energy is going to be produced, but it probably is a good idea to put a negative sign there. So if I were to do this again, I would probably include the negative sign. But the bottom line is we are going to produce 404.2 kilojoules of energy. I got to switch slides here now. Okay, so now we got to go back and talk about standard enthalpy of a reaction. The definition, the enthalpy change that occurs in a system when matter is transferred by a given chemical reaction, when all reaction products are in their standard states. We previously calculated the enthalpy of reaction using bond energies, and that is the quiz that you took online, and it's number 5 on that quiz that you're supposed to hand in and show me that you know what's going on, which most of you so far are doing great. But just a refresher, here's how we work with bond energies to calculate the enthalpy of the reaction. Bonds broken minus bonds formed. The enthalpy reaction is negative 124 kilojoules per mole. So nothing new so far. But here's the new stuff. The enthalpy of reaction for a given reaction can also be calculated using enthalpies of formation. The enthalpy of the reaction can be calculated by the summation of the enthalpy formation of the products minus summation of the enthalpy formation of the reactants. We talked about this earlier in the year. Oftentimes in chemistry, it is products minus reactants. So we can calculate the enthalpy of formation of a reaction by using the table of enthalpy formations, subtracting the summation of all the products, and we subtract from that the enthalpy of formations of all of the reactants. Here is an example I'll work out with you. Calculate the enthalpy reaction for 2CO in the gaseous state plus O2 in the gaseous state plus 2, we're going to form 2 CO2s. So we're going to calculate the enthalpy reaction, which is the enthalpy of the summation of the enthalpy formation of the products minus summation of the enthalpy formation of the reactants. So I'm going to use table A6, which I'm going to post in Google Classroom here momentarily, which is going to have all the values for the enthalpy formations of some common compounds. So I'm not going to use the one that is posted in Pearson. I'm going to use one that I have included as a PDF for you. So basically, we're going to take the enthalpy formation for 2 moles of carbon monoxide, 1 mole of oxygen, and we're going to subtract that from 2 moles of CO2. Remember, in this case, it's products minus reactants. Make sure you're paying attention to the state of matter, because the enthalpy formation are different for each state. So I took 2 times the enthalpy formation of carbon dioxide, which is negative 393.5. Again, you can find that on table 8.6. 2 times the enthalpy formation of carbon monoxide. So we have 2 carbon monoxides up here. And it's going to be 1 times the enthalpy formation of oxygen. So I have 2 times negative 11 and then 1 times 0. Now oxygen is enthalpy formation is 0 because it exists as O2 in the standard state. So its enthalpy formation is 0. So it's very similar to the bond energy, but you got to be careful. Enthalpy for reaction using enthalpy formation is products minus reactants. So I did the math, boom, came up here with negative 565 kilojoules per mole. So the enthalpy of reaction for this reaction here of 2CO plus O2 forming 2CO2 is going to be negative 565 kilojoules per mole. Based on the enthalpy change, determine whether the reaction is endothermic or exothermic. Well, a negative delta H is indicative of an exothermic reaction. Let's try one more. Remember, enthalpy of reaction can be calculated by using enthalpies of formation. It's the enthalpy of formation of the products minus the enthalpy formation of the reactants. So it's products minus reactants. And again, make sure you refer to table A6, which I've posted in Google Classroom. Those are the values we're going to use to do this. So again, I have 3 moles of CO2, so I have 3 times the enthalpy formation of CO2. 2 moles of iron, so it's going to be 2 times the enthalpy formation of iron, minus the enthalpy formation of 1 mole of Fe2O3 and 3 moles of CO. We do the math, I am getting an answer of negative 26 kilojoules. That should be kilojoules per mole. So make that note, that should be kilojoules per mole. So this reaction is going to be exothermic because it is negative. So that is how you calculate the enthalpy of reaction using enthalpies of formation.